Hello, and welcome to this Eckerson Group webinar about democratizing data consumption with Data Fabric. I'm Jay Piscioneri. I'm a research analyst with Eckerson Group. I'm here with Joe Lichtenberg of InterSystems, who's head of product and industry marketing. Welcome, Joe.
Hi, Jay. Thanks for having us.
Sure. Our agenda for today is we'll go over an overview of Data Fabric and how it democratizes data, and then Joe will follow up with InterSystems Smart Data Fabric. After that, we'll open it up for Q&A. One thing also that I want you to know is we're recording this session, and we will be sending out a link to the recording as well as the slides from this session to everyone who is registered. With that, let's dive in. Okay, so we'll start by looking at how data architectures have evolved specifically for analytics, and going back to starting with the data warehouse, which was conceived in the 80s. And it was conceived to help make data easier to find and use for reporting and analytics. So democratizing data has been around for quite some time. The data warehouse was optimized for what we would call business intelligence types of workloads. So reports, dashboards, primarily for business consumption. A couple of the characteristics of data warehouse that we'll be comparing through the other architectures are it's based on centralized storage. The data is highly prepared and by a centralized team into a standardized and structured format, and it's managed centrally. So this worked for quite some time until the big data revolution and the rise of data science, at which point the data lake came on the scene, and that was really optimized for data science workloads, which required data in its native format. So the data lake, like the warehouse, is also based on centralized storage, but one of the big differences is that it's, as I said, it's left in its native format, and that enables the consumers of the data to prepare it in any way that they need it. So it gives a lot more flexibility, especially for data science type of applications, to format and prepare data for specific use cases and modeling and so forth. In the data lake, unlike the warehouse, there are many different formats of data that come along with the modern data environment, but still the data in the data lake is centrally managed. Now, these two architectures solve problems, but not all problems, and they each have their sweet spots. So Data Fabric looks to incorporate the benefits of both of the data warehouse and the data lake. Data Fabric incorporates those structures specifically, but it's really optimized for adaptability across a lot of different workloads, including real-time business operations. So it's based primarily on distributed storage, and one of the characteristics of the data lake that really starts to make it different from previous architectures is instead of just relying on preparation by either a centralized team or distributed to data scientists and other consumers, the Data Fabric calls for as much automation as possible, especially in the preparation of data. And by what I mean by that is transforming data, cleaning it, normalizing it, etc. You can connect to data sources through a variety of methods, including APIs, and it also accommodates streaming data. Another facet of automation is data management automation, and we'll dig into that in more detail in a moment. So, Joe, what's your take on this evolution?
Yeah, I think that's right. And I think, in this slide and in the white paper that you wrote about this, it was really helpful to talk about the differences between a data fabric and versus a data warehouse and a data lake, and other approaches as well. So this is really helpful. I think what's interesting is, many of the customers that we talk to, they already have a data warehouse and also likely a data lake installed and in operation. So they really want to understand the differences between data fabric and prior approaches. So again, I think this is really helpful. The other really common question and request that we get is customers want to be able to continue to leverage their investments in their prior approaches in data warehouse and data lakes and other data silos, and to really understand how a data fabric can treat those other initiatives as sources into the data fabric. So to be able to leverage the data and the queries from the data warehouse and the data fabric and the data that's in the data lake as sources into the data fabric. And so we see that as a common pattern to be able to reuse those prior approaches. Do you see that as well, Jay?
Yeah, definitely, and I think that's one of the important characteristics of the fabric concept, which is that it, whatever your data is, in whatever form you prepare it or store it, the fabric wants to connect it and make it easier to find and use. So it's really kind of, and the metaphor of the fabric is you lay it over what you've got and add to it, right? And it covers the entire data landscape.
Right. That's exactly what we see as well.
Yeah. So let's talk about what a data fabric is exactly. So first of all, it's an architectural approach, and I would say, the architectural approach, that phrase means that it's not a specific architecture. There are a lot of different ways to build a data fabric, but the architectural approach is to use metadata, machine learning, and automation, as well to weave together data from any format and any location. And I apologize for the pun there, but I couldn't resist. And the objective is to make data easier to find and use by people and systems. So that's an important another important distinction, is that other systems need to be able to consume data as well as people in the company. And as I mentioned, automation is an important facet of the data fabric, and specifically around automating data management functions, such as integrating data and making data available in its native format, preparing data, which is all the transformations that we just talked about, such as cleaning it and normalizing it and reorganizing it for specific purposes. In addition, you have cataloging, which is creating and managing metadata. And Fabric brings automation to that, which we'll go into in a moment. Access management, making sure that the right roles can see data to the right degree, and then discovery, making it possible to find data through browsing and searching, and other methods to surface what data is available, what it can be used for, along with other details such as sample data and sample queries, etc. Yeah, so let's dig a little bit deeper into the components of the data fabric. So ultimately, a data fabric is there to connect data consumers with data sources, and it starts with a set of processing layers that manage connectivity through connectors or APIs and SDKs, an abstraction layer that allows you to build and model views that are both location and format agnostic, and retrieval to pull back data according to specific criteria, needs of the moment or part of a pipeline, and then access control, as I mentioned before, which includes role-based access as well as attribute-based access control, such as masking and hashing and encrypting specific data columns and cells using criteria that are evaluated at runtime. The layers that the consumers interact with primarily are what we call the application functionality of the fabric, which includes discovery, searching and browsing and profiling data, viewing samples, so that consumers can understand what the data that they're finding actually consists of and how it can be used. In addition, there's the preparation, because you have, in order to prepare data for, say, a certain model, you have to structure it, clean it, combine it with other sources, etc. And then there's cataloging, which involves labeling data and classifying, tagging it, annotating it with user ratings or comments about how well, how trustworthy it is and whether it serves a given purpose well. Joe, does this align with your idea of how of your idea of a data fabric?
It does. I think it's a very clear description. As you said, a data fabric can be comprised of many different individual data management services, depending on the use case, right? It's always the use case that drives, what the specific implementation is going to look like. So I think this diagram is really well aligned with what we're seeing as well.
Yeah.
I think it's helpful in the paper, in your white paper. You had an entire section devoted to what a data fabric is not. And as sort of illustrative and helpful as this diagram is, I also found that section to be really helpful, right? So I think there's a lot of sort of fuzziness in the marketplace around what is and what is not a data fabric. And so in your white paper, you talk about individual services like data virtualization and other individual data management services that very often we see as components in a data fabric architecture, but they're just individual services. They're not the data fabric. The data fabric, typically is going to be comprised of much more than just one or a few individual services. And that's, sort of a big part of the automation and what makes it so powerful and functional and so applicable to many different use cases. If I may, Jay, one question that I actually get a lot is whether a data fabric is different from a logical data warehouse. And in your doc, you have a section on the difference between an LDW and a data fabric. Maybe talk about that.
Sure. There is a difference in the sense that the data fabric is much more open to a variety of data structures, right? So going back to what we said before, a critical use case is providing data in its unaltered format from the source, which is the starting point that data science needs. If you have, say, for example, a star schema, a lot of processing has gone into creating that star schema, which may pull out data that is useful for a modeling, an AI ML modeling use case. So, and then, like you said before, there's a data fabric doesn't really take a stand on whether things should be virtualized or persisted, right? In fact, I would argue that it explicitly means that you can have and should have, as needs dictate, both. So Yeah, I think there's a logical data warehouse is something that we talked about a lot many years ago, but I think Fabric is more flexible for many more kinds of use cases. So.
Yeah, and much more functional as well.
Yeah.
And what we say, so you said, there's a sort of optionality around whether you virtualize the data or whether it's persisted. We say a data fabric should support both connect and collect paradigms depending on the use case.
Yeah. Yeah, and when you and I spoke a while ago, you used that phrase. I really like that phrase. I think it just really captures it in a nutshell. Yeah, so a couple other aspects of the fabric here and for me, the metadata that lives behind the data fabric is, to me, sort of like the threads of the fabric, right? All these services both create and consume metadata, and then the AI and machine learning aspects of the fabric, which I'm going to go into next in a couple of examples, really feeds on this metadata to make it all work and make the automation that helps scale data management in our modern expansive and complex data environments feasible, where manual data management and governance is struggles to keep up with the volume and velocity of data as it is today. So some examples of AI and ML use cases in a data fabric are first discovery. So sometimes you can use natural language processing in search to enable a business user, for example, to pose a question, such as how many customers are likely to churn in the next 3 months. You type that sentence into a natural language search service, and that model can return resources that exist within your fabric that are, for example, what data sets would you need to answer that question? Or if somebody's already built the model and a data set already exists with, say, for example, a churn score in it, that kind of discovery is a much easier way for business consumers of data to find and access the data they need. In addition, using AI/ML to generate code, most often SQL code, to find data, bring it back, prepare it. These models can profile the data, figure out how to build joins and how to filter data for specific purposes, and also you're using AI and ML for monitoring the data quality and taking action on various issues that may come up, self-regulating and validation of data. And then our last example is in cataloging. So if you are onboarding a new data source into your fabric, there are many of the things that you need to do, such as a critical one is identifying sensitive data like PII, PCI, PHI. There are many automated functions that can find and tag that data, which then feeds into your access control, so that you can either not expose that data to certain roles or expose it with the appropriate masking or hashing that makes it usable but not identifiable. So let's talk about the abstraction layer, because to me this is kind of the heart of the fabric and where all the magic kind of happens. So I'm sure we're all really well acquainted with the fact that the modern data environment is extremely complex, and that creates a tremendous amount of friction for data consumers to use data from the actual sources. So the abstraction layer is intended to simplify getting at data by basically hiding where data is and what format it's in. And so that abstraction layer, whoops, sorry, wrong button. That abstraction layer creates what we call abstracted data objects, which have those location and format details obfuscated, so that the consumer doesn't have to worry about where it is or how to query it. These abstracted data objects, as we said earlier, can be either virtual, and there are definite advantages to virtualizing these, storage and security concerns around copying data, storage costs. However, that's not always practical. So as you said, Joe, you need to be able to collect and connect, and that's what the abstraction layer is intended to do. Yeah. What do you think about this? Is this kind of the heart of it, as you see it?
Yeah, it's a critical part of it. And looking at this slide, it looks very similar to what we were doing starting back in the early 2000s with web services and exposing endpoints with WSDL and building service-oriented architectures. It's fundamentally the same concept, right? We're creating an abstraction layer over the endpoints, and then being able to orchestrate and reuse components to create new composite applications and other use cases. So conceptually similar, but obviously Data Fabric, takes this abstraction architecture to a whole new level.
Yeah, and kind of what you just mentioned about using this abstraction layer to create further abstractions. In this example, you could use these abstracted data objects to pull derived views that show, for example, all purchases from the various sources that you have that capture purchase data, or create a churn model out of the raw data that exists. And the people who would be doing this don't have to worry about, again, what the complexity that lives below that abstraction layer. They can just get to work deriving insights. So there are a number of different approaches to using a data fabric, which kind of depends on what your organization is looking to do. So there's the use case of business empowerment, which is, as we've said, making data easier to find and use. If that's your primary concern, then some of the stuff that we've spoken about, in particular, like natural language search or the preparation, no code, low code preparation capabilities are really critical. But then in a more advanced use of the fabric is to focus on not only those use cases, but also the data science use cases. And as we said, having the data available in its unaltered form is an important requirement for modeling in AI and ML. And in addition, the ability to manage data, the management of data, governance of data in an automated fashion, so that you can keep up with the volume is kind of part of the next level of sophistication in using data fabric. And then finally, we've been talking about this the use of the fabric architectural approach for analytics, but it can also be used in operational data management to tie applications, to get data between applications, make them available for that, including all the way out to the edge of the landscape where IoT devices live. So it's a very flexible approach, and there are some important concerns that when you actually are going to take this on to consider, which start with assessing your current data management process and systems. How mature are your processes? what investments and tools and processes have you made that are delivering value? Where are the pain points? And then prioritize where data management and consumption improvement are going to have the biggest business value. And that leads to wherever those areas are, do you have the skills needed to close those gaps? Data fabric involves a lot of integration work, and you need a certain set of skills depending on where you're going to shore up first, and that's an important thing to consider when you're doing these when you're taking on a fabric project. And then lastly, I think you can see that data fabric covers a lot of different aspects of the data landscape. So it would be the risk here is that you could take on too much and attempt to boil the ocean, so to speak. And so start small and build out. Focus on the areas that will, the aspects of the fabric functionality that will deliver the most improvement, and that goes back to the different approaches we just spoke about. And try, iterate and build it out as you go. So with that, Joe, I'm going to hand it over to you to tell us about InterSystems Smart Data Fabric.
Great, thanks, Jay. And all of this is not only great, but it's really aligned with what we're seeing as well at InterSystem. Okay, so I am going to hopefully share my screen. And click on that. We'll click on that. Okay. Can you see my screen?
Yep.
Ah, it worked. Perfect. Okay, so thanks again. I think before I get started, just a little bit of background if you're not familiar with InterSystems. So at InterSystems, we're a data management software company. We've been in business for 44 years. We have thousands of customers in every industry around the world. We have a number of products. Our flagship software product, InterSystems Iris, is a next generation data platform. It provides multi-model and multi-workload database management capabilities. It has a full integration platform. It has a wide range of analytics capabilities, all in a single engine, in a single product that's built from the ground up. And we're addressing with our software a wide range of use cases, literally for thousands of customers in every industry around the world. In my role here as head of product and industry marketing, among other things, I work with our customers and partners to help them try to find the best ways to solve their different business and technical challenges. And I'll talk about some of those. And so background for me, I've been in the data management space, let's just say for more than 20 years. I've worked with many different technologies and customers along the way. Okay, so in my section here, I want to talk about really what we're seeing in the space. So for many of us, like us, Jay and I, we've been in the industry for a long time, and we know these things that we're talking about aren't new problems, right? So organizations have been wrestling with these same problems for decades. How do they get more value from their data when it's locked away in silos? How do they reduce the delays and the latencies and the complexities associated with getting value from the data? How do they give the business the self-service capabilities they need so that they can make better decisions in the moment without having to go back to IT and so on. And again, as Jay described, we've seen many different technologies and approaches over the years to try to solve these problems. And by the way, not just data warehouses and data lakes, but I've seen many companies struggling with manual coding and batch copying of data and point-to-point connections and spreadsheets and web services and others as well. And so that's what the data fabric, or here at InterSystems, what we call a smart data fabric, is really all about. It's a better way to connect the consumers of the data, including business users and data scientists and quants and customers and partners and your applications with the real-time and consistent, integrated, harmonized data that's typically distributed inside and outside the organization. And there's a whole range of different business initiatives, as Jay talked about. And I think what makes this new approach so popular is that it is able to address many of the limitations of these prior approaches, right? It's a fundamentally different approach in that it's able to access the data from these variety of different source systems in real time, as it's needed by the consumers of the data, and apply a whole range of different processes to the data, dynamically in flight while it's being accessed, rather than in batch mode for things like integration and validation and reconciliation and data pipelining and all sorts of analytics, from business rules to BI cubes to machine learning and others, natural language processing Jay talked about. Ultimately, so the business can make better decisions with better, more accurate, more current data. And you can streamline and automate your workflows and your business processes using more data from more sources, all in real time or near real time if it's needed. So I always like to start with what are the business challenges that customers are trying to address, right? Technology doesn't exist just for the sake of technology. It's to solve business problems. So what is the business still struggling with? So this is an interesting slide for me anyway. Here's some data from a recent survey that we ran of 554 line of business executives from organizations around the world. And 86% told us that they lack confidence using their data for making decisions. That's a huge number, right? 86%. And why is that? So there's a number of reasons, but the number one reason that they tell us on the left is that they say it takes too long to access the data, by which time it's outdated, right? And if you think about sort of the batch processes and all the work involved in making the data fit for purpose, we know that that's true. And if you look at the data on the right, only 5% of the data that the business uses to make decisions is less than an hour old, and 63% of the data is more than a day old. And with disruptions and exceptions and sort of real-time triggers happening more and more often, greater frequency, even greater volatility, very often end-of-day data and even intraday data is very often insufficient. And then, it's interesting, if you look back on the left, you can read some of the other top challenges from the business around being able to use their data. They complain about the data being in disconnected silos, which we know, getting the data in the right format so that it's useful, having access to more data or all of the data that they need to make decisions. And of course, data democratization, in large part what we're talking about, which is giving the business access to the data and the tools that they need to be able to get the information that they need in the moment, not a day later or a week later or a month later, so they can make more informed business decisions when it matters. And so, these are exactly the challenges that data fabrics are addressing, and that's why it's important.
Yeah, I think this is really interesting data. And another thing that jumps out to me, especially around the how old is the data. So it looks like there's 21% of your respondents are working with data that is more than weeks old. And yet at the other end of the spectrum, you've got about 18% of the respondents who have intraday or better data. I think that range of experience is interesting. What do you think that tells us about the state of data management, Joe?
Yeah, Jay, it's a good question. I would say first, not every use case requires real time or near real time or
Mhm.
even intraday data, right? So there are plenty of weekend or batch or month end use cases. So I don't think that near real time number is ever going to be 100% because I don't think it needs to be. But on the other hand, there are many use cases, and we see them in financial services and disruptions in supply chain and on the manufacturing floor and in retail with customer next best action, in healthcare and even in the public sector with citizen self-service and fraud detection and so forth, where they really do need real-time data, both for operational workflows and to make decisions. And again, the number one response from the survey is around latency. So it is a big problem. And I think, with these things that we're talking about, I think, we are going to see that number shift to more, lower latency, real time, near real time, intraday, as needed, dictated by the use case. And it is moving in that direction, but it's a process.
Yeah.
Okay. Okay. So next, what I'd like to talk about is what we're seeing data fabrics look like in practice. And so I thought it would be interesting to take you through two different use cases, each from a different industry. So the first use case that I want to talk about is from one of our customers. They're called UST Global. They're in the supply chain space. They have more than 30,000 employees. They're doing 1.6 billion in revenue. They're a global organization, so they're a big company. And they provide software, and they also have a large professional services organizations. And the area where they're working with us specifically is for their software around optimizing supply chains for their manufacturing, retail, and CPG customers, which today, I think is more critical than it ever has been. We're all painfully aware of the impact of the pandemic and post-pandemic, and it's still wreaking havoc with supply chains. So this is a really current and significant challenge for a lot of organizations. So UST Global provides a supply chain software platform, a product that they call UST Omni. And what UST Omni does is it provides their customers with real-time visibility into their extended supply chains, which has lots of different vendors and systems and so forth, from suppliers all the way through customer delivery. And one of the things that it does is it senses disruptions and exceptions in the supply chain in real time. So for example, if a shipment is to a customer's late, if a cargo ship is being held up at port, and if an order is incomplete and it's missing some line items, and then it also provides the supply chain managers and executives with what they call actionable insights and recommendations that are based on running prescriptive machine learning models in the moment, in real time, to help them and guide them in the best ways to handle these disruptions that are happening in the moment, and also to calculate what are the trade-offs of each of the different options, because any action that they take can have significant sort of impact and repercussions, both upstream with suppliers and downstream in delivery to the customer, right? So it's really an ideal initiative for a data fabric architecture. Number one, to provide this sort of real-time visibility, so it's a data silos problem, and data-driven guidance across the entire extended supply chain. So there's analytics involved and so forth. So it's a fairly complex business use case. And so working with us, our customer UST Omni, is not only providing real-time visibility across supply chains and real-time alerts when there are exceptions and disruptions in the flow, but they're also able to deliver these predictive and prescriptive analytics and guidance in real time using embedded machine learning models to help them identify and recommend different actions that their customers can take to remedy these disruptions and exceptions. And it also calculates the projected trade-offs and the costs associated with each one of these potential actions so the customers can make the best decision. And it's a really complicated problem because, as UST tells us, they say there can be as many as 40,000 different data points involved in any of these calculations. And so by doing this and rolling this out to their customers, they tell us that the benefits that their customers are seeing are around improving their ability to fulfill orders on time and in full. And they're doing it at lower cost with less disruption to their organization and without impacting their other customers. And so I really like this example. I think it really shows sort of the power, the flexibility, and the real-time and near real-time embedded analytics that they're getting with a data fabric architecture that they just wouldn't be able to get with a data warehouse or a data lake or a different approach. Okay, the other use case that I want to talk to you about is in the financial services space. So this is another one of our customers, Broadridge Financial Solutions. They're one of the largest fintech software providers in the world. They do $5 billion in revenue. They're publicly traded. They currently have a $16 billion market valuation. Their stocks included in the S&P index. So they're a major fintech. They service almost every major Wall Street bank. They process over $7 trillion with a T in equity and fixed income trades every day. And the company's been around for a long time. They were spun out of ADP, the data processing firm ADP, back in 2007. But before that, within ADP, they'd actually been in operation for decades. So like any company that's been around for a long time, they have lots of systems and silos. They've made lots of acquisitions, all bringing their own application software and infrastructure software, and they have organic development. So today they're currently operating more than 100 different applications, many of them with different data and different formats and different structures. And so what they were looking for was a better way to bring together all this data into what they call a clean, current, and consistent format to service their internal stakeholders, their external stakeholders, their customers and partners, and get synchronized data with analytics embedded across all their applications. And so they initially looked at doing this a variety of different ways. They looked at a data lake, they looked at a data warehouse, but they wanted the advantages, Jay, that you were talking about. They didn't want to create more copies of the data. They didn't want more data silos. They wanted real-time performance. So they came to us looking for help in building out a data fabric. And so that's what they did. And so this data fabric architecture that we built with them, it accesses and integrates all of this different data on demand as it's needed from the different applications and silos. And there's a lot of built-in analytics involved. So there's real-time transactional and pricing data and financial calculations that have to happen on the fly with sub-second performances, you can imagine, with a financial services company for things like positions and valuations and so forth. And it feeds their internal business users and their customers and their applications with consistent and clean and real-time data. And it's a very modern architecture. It's running completely in the AWS cloud. And so, Jay, as you talked about in your white paper and, in your slides, there's, many different data management services that are required. And so, initially Broadridge looked at building this out using many different individual services from a public cloud marketplace, including multiple databases and a data warehouse and a caching layer and search technologies and so on. But it would be very complex. They'd have to learn and provision and integrate, manage, and maintain all these different systems, and then copy data between them. So there's inefficiencies. But instead, by working with us, they're able to get many of the capabilities that they needed in one platform without moving or copying the data. So that meant faster time to value, a simpler architecture, simpler implementation, easier maintenance. And because you're not moving data around among different systems, they're actually gaining a 9x increase in performance on only 1/3 of the infrastructure compared with that other approach, working with InterSystems. Okay, so very quickly, I want to talk about our view of a data fabric, what we call a smart data fabric, which is very much aligned, Jay, with what you talked about. And again, it's a fundamentally different approach that connects your consumers of the data to your source systems and your data stores on demand. Very different from batch mode, eliminating the latencies and the complexities that are usually associated with batch approaches like data warehouses and data lakes and copying data and so forth. So with a smart data fabric, real-time data, including event data and asset compliant transactional data, could be combined with any other type of data, historical data from your operational systems and production applications, and from external data providers, and from your data lakes and your data warehouses and so forth. And it's all can be ingested on demand and have these various processes applied to it for integration and transformation and process automation to get it all into a consistent format. And then also what we see is the need to have a wide range of analytics applied to it right in the fabric for things like analytic SQL and business rules and business intelligence and predictive and prescriptive analytics, again, all on demand right within the fabric, right as the data is being accessed from the source system. And Jay, as you pointed out, all with a common metadata and semantic layer and full lineage and with consistent and overarching security. And then the data and the analytics can be presented to business users that allow them to drill into the information, to ask them questions and be able to do data discovery and drill into the information. We see use cases where the data is presented to the data scientists and the analysts and the quants for their use as this current and consistent data science workbench where they can experiment with the data and build and tune machine learning models without taking these huge extracts and the delays and complexity associated with that. Obviously, it can be externally facing for your customers and partners. And we talked about feeding your applications with live and integrated and harmonized and accurate data. But there's many, many different use cases that we see. And by the way, interestingly, many of the sort of the canonical definitions of a data fabric, and there are many, it's still sort of this evolving architecture, but many of the definitions that we see don't include analytics capabilities directly within the data fabric. So you have to take the data and then move it to another environment for analytics. And we think this is wrong. We think that analytics is, in fact, a critical set of functionality for most of the use cases that we see. And that's why we provide all these analytics capabilities directly within the fabric. So you don't need to copy the data to a different environment. And that's actually the reason why we call what we help enable a smart data fabric. And then we also think that a data fabric should provide a rich development environment so that developers are able to easily build new composite applications using all of the data and functionality that's in the fabric for things like Business 360, where you have a current view across silos within the business, Customer 360, so every touch point for every customer interaction, and then how do you predict what customers will want to do next and next best action and prevent customers from churning and so forth around supply chain, enterprise risk in the manufacturing space, IT/OT convergence or Industry 4.0, right? And many, many other use cases. And so having that built-in development environment we think is critical. Just on my end to wrap, we still have 10 minutes left. Again, InterSystems, we've been in business for 44 years now. We have thousands of customers in literally every industry around the world. And we've been providing data management software to our customers. We're at the core of some of the world's most data-intensive applications. We like to say we're sort of like the Intel Inside in mission-critical data and analytics applications running at scale. Our software is managing more than 1 billion electronic health records for patients around the world. Our software is processing more than 2 billion real-time stock and multi-asset trades every single day. And of course, we're in many other industries as well. Okay, so that's me. Jay, I think if I turn it back to you and open it up for a Q&A.
Yeah. So thanks, Joe. So folks, if you have questions, please use the Q&A button to post them. We already have some that have come in. A common one is, can we share the link to the white paper, which should be in the chat now, but we'll also include that in the follow-up when we send out the link to the recording and the slides, which everybody who's registered will get, will receive those links. But here are some questions that we've gotten. One is, what are the differences between data fabric and data mesh, and can they be combined? And that's a great question. So first of all, there's a lot in common between data mesh and data fabric, but there are some distinct differences. So what's in common is, it's another approach to trying to solve these problems of making data available and understandable and usable in a lot of different environments, in a lot of different use cases. And given the vast complexity of the data environment, it's a critical challenge that everybody's still working on, right? So that's what's in common with data fabric and data mesh. What data mesh, the principles of data mesh that are unique to data mesh from data fabric are, there are some significant organizational changes that represent a paradigm shift in how data is dealt with, and they are described in there are 4 pillars of data mesh. 2 of them are about organizational change, I would say. One is domain ownership of data, and by that it means that the teams in charge that are close to where the data is being created work closely with the business processes that the source applications are facilitating. Those teams should own and manage their data. So it's really breaking the pattern of a centralized data team versus distributed responsibility for data. That's critical. The other, and that means that instead of having all your data engineers and data analysts in one group that kind of came out of the data warehousing approach, is that those skills need to be distributed to different domain teams. The other significant conceptual difference is treating data as a product, and what that means is bringing product thinking to the data itself. So the teams that are creating application functionality and creating software for external customers to use are very familiar with this notion of product thinking and what does the customer need, what will deliver value to the customer. In this case, we're talking about data consumers as the customers. What do they need? And then these domain teams would own creating data products that solve these problems. So they would have to know what the problems are and how to create the data. So those are 2 significant differences around Fabric and around data mesh that Fabric doesn't really take a stand on, right? Fabric is really kind of talking about the technology that makes all this happen. So one of the things you said, Joe, in your presentation actually reminded me of an important aspect of a constituency that needs to be served are these domain teams or the developers of the data, right? They need a seamless process that makes it easy for them to respond to their stakeholders' needs, as opposed to hunting around for all the data and figuring out how to mash up all these different formats and so forth. So that's another important point about data mesh that I think kind of aligns with data fabric, which is the notion of a self-serve data platform, right? And it's not just self-serve for the consumers of data, it's also self-serve for the creators of data. So in the data mesh paradigm, where creation of data products is distributed amongst the throughout an enterprise, all of those creators of data need a way to be able to prepare it, have a place to put it, and not have to have a long approval-based process to allocate resources, technical resources, infrastructure, and so forth. Data mesh calls for all of that to be as automated as possible, so that a data engineer can spin up an environment to start doing the development work on their data product and test it, and then publish it to a place where it can be found and used by the consumers. And then the other aspect of data mesh that I think aligns with Fabric is the concept of federated computational governance. And what that means is, again, federated it means that it's a team of representatives from the domains that create data products help do the governance. So the reason for pushing ownership out to the domains is to give them more autonomy and let them produce products that in response to their stakeholders' needs as quickly as possible, without having to go through, again, another centralized approval process to say, is this data acceptable to make available for people to use. That process, the computational part of federated computational governance, is that guardrails are defined by the federated team and then implemented as code, essentially, that applies standards when a data product is created. So it's about automation of data governance and data management, which again aligns very closely with what Fabric does. So that's how I see data fabric and data mesh comparing. Joe, anything you want to add to that?
I think that was a good explanation. That's probably the most common question that we get.
Yeah.
And so our stance is they are complementary. And if you have a centralized sort of data governance, Office of the Chief Data Officer, you will most likely want centralized governance and a data fabric architecture. If you want or need to have innovation or ownership happen at the edges of the organization, maybe there's data sovereignty issues, maybe you want to empower edges of the organization to be able to go and innovate, data mesh approach can operate there. And again, they're not exclusive, they're complementary. So we have customers that actually are doing both, right? They have a data fabric architecture in place, but at edges of the organization, either because they have to, because of security, data sovereignty, or because of trust and innovation and allowing edges of the organization to innovate. They have data mesh architectural implementations happening in certain areas of the organization locally.
Yeah. So a couple of quick questions. Here's one about the InterSystems Smart Data Fabric. Is the InterSystems SaaS a managed service offering?
So we are very flexible. We run on-premise in private cloud, public cloud, any combination, hybrid. You can own and operate it yourself. You can rent it. You can run it as a service in the cloud, a managed service. So many different deployment options and different pricing options as well, both OpEx and CapEx. We're very flexible in just working around both the sort of the deployment requirements and the pricing requirements. And sometimes a common use case is you have data that needs to be on-prem, but not all of it. Or you need very high performance for certain parts of the applications, especially in financial services. And so you want that part of the application, the data to be on-prem and the rest to be in the cloud. And so, any sort of permutation that you can imagine, we have customers doing that.
All right, well, that brings us to the end of our session. There are some questions here that we didn't get to. We'll follow up with those when we send out our links. Thank you, everybody, for attending. Joe, it was great to spend the time with you, and everyone have a good rest of your day.
Yeah, great to be here. Thanks, Jay. Thanks, everyone.